All right, so those online and those in the room are about to start the thesis defense for Lindsay Martinez. So Lindsay came to us from Great Falls, Montana. She received a bachelor's in Princeton in ecology, and she began her master's work here at A&M. Her thesis title today is Scientific and Socio-Political Planning for Ocelot Reintroduction in Texas. I'm a bit surprised that she used the word political. I don't know what politics are involved in ocelots, but maybe we'll learn a little bit about that today. This project was really a partnership of various groups. Of course, Texas A&M, Caesar Clayburgh was a key partner, the East Foundation, Cincinnati Zoo, Fish and Wildlife, and so forth. Always the danger of mentioning partners because you'll probably forget someone, but hopefully not. But with that, I'm going to let Lindsay kick us off. We can maybe close the door, make sure it's unlocked if you don't mind. And, normally what we do, we'll do a 30-minute, 40-minute presentation. There'll be questions from the audience and online, and then the committee will continue to visit with Lindsay afterwards and hopefully get her finished up here. So Lindsay.
Thank you. Thanks for introducing me, and welcome everybody to my master's presentation, Scientific and Socio-Political Planning for Ocelot Reintroduction in Texas. I wanted to start by saying thank you to Dr. Lopez as the head of the department, my advisor, for working with me throughout the project here, as well as thanks to Dr. Grant for being a member of my graduate committee and being here, and thanks to Dr. Campbell for being a committee member and working with me on the project. Thanks as well to everybody for coming today, and for anybody who's watching online as well. Appreciate your interest and your support. And for the folks who don't know me, I wanted to say a bit about myself. As Dr. Lopez said, I grew up in Great Falls, Montana, and thanks to my really wonderful family and friends, my childhood got to look a lot like this. I did a lot of skiing, a lot of hiking, fishing, and camping. And for me, the highlight of any outdoor experience was always getting to see wildlife. And so I grew to have a love for all creatures, great and small, as well as really a dream to protect at-risk wildlife so that people like me could keep dreaming about seeing them in the wild one day. So I've got to have some great wildlife experiences in the past, but for me, it's always come back to wildcats, endangered wildcats. That's been my dream since at least 2004. And so I was so happy in 2020 when I got to come to Texas and get involved in research and conservation for endangered ocelots. I'm looking forward to talking about what I've been working on with my master's degree the last few years. So my overview for today, I'm going to give a bit of background into ocelot conservation in Texas, talk about this new ocelot reintroduction study that I've been a part of, and then go over 3 objectives from the study, including identifying a reintroduction site, doing some population modeling, and then looking at policy for ocelot reintroduction and endangered species conservation on private lands. So to start, the ocelot. So it's a medium-sized wildcat species that, as a species, it's not at risk of extinction. There's ocelot populations found throughout the northern half of South America, throughout much of Central America, and then as far north as the southern United States in Texas. And in Texas, historically, if you see the green, ocelots existed in some various regions, all along southern Texas, going up sort of towards central Texas, and then out to the forests of East Texas. It's also believed that ocelots historically occurred in Arkansas and Louisiana. But if you look in the red checked counties, those are where ocelots have been seen in about the last 30 years. So there's been a big decline in ocelots so that they only occupy a small bit of coastal South Texas today. So what's the reason for this decline of ocelots historically? The first would be historic overkilling or overexploitation of ocelots in Texas. That could have occurred through predator control efforts like indiscriminate poisons that were put out across the landscape in Texas. It could have been capture of live ocelots for sale as pets like Salvador Dali had, or it could have been killing of ocelots for harvest of their pelts to sell those as fur coats or the backings of chairs. There was actually a really large global ocelot trade in about the mid-1900s. Much of that trade was ocelots from South America going into Europe. But ocelots were killed in an unregulated way in Texas until they were listed as a domestic endangered species in the US in 1982. The other historic threat to ocelots, of course, was habitat loss. And ocelot habitat today looks like this. It's live oak forests, it's Texas Tamaulipa and thorn scrub. It's characterized by, mesquites or other trees in the canopy, and then some various herbaceous vegetation or woody, thorny vegetation in the understory. And of course, these sort of wild and densely vegetated landscapes didn't survive historic urban development in Texas or clearing of lands for croplands or pastures. And the only occupied ocelot habitat that's been maintained in Texas today is in very southern coastal Texas. And there's only 2 ocelot populations that are known to be remaining in Texas, and those are the only ocelot populations in the entirety of the United States. So in the very southernmost county of Texas, we have the ranch ocelot population that lives in and around the Laguna Atascosa National Wildlife Refuge, believed to be up to 20 individuals there. And then in a completely isolated population to the counties just to the north, there's this ranch population of ocelots living on private working ranchlands. It's estimated that there might be up to 70 ocelots in that population, but the exact population size and the extent of that ranch population isn't exactly known because some private landowners don't survey for ocelots or disclose the results of those surveys due to some concerns about Endangered Species Act regulations applying to ocelots and their land uses. So there's a small number of ocelots remaining in Texas. They live in a limited range in coastal South Texas. And in a future where we expect sea levels to be rising, tropical storms or hurricanes might increase in their frequency or intensity due to climate change, the viability of these Texas ocelot populations that live almost exclusively in low elevation coastal areas is definitely of concern. A single catastrophic hurricane could impact that entire range that ocelots occupy in the United States. And it doesn't just have to be a hurricane. Other catastrophic events like wildfires or disease outbreaks could impact that whole occupied ocelot range. So the U.S. Fish and Wildlife Service has a recovery plan for ocelots. And this plan states there needs to be at least 200 cats in Texas for the ocelot to be delisted from the Endangered Species Act. And one priority action for achieving this recovery is to reintroduce an additional population of ocelots back into some of their historic but now unoccupied range in Texas. And that reintroduction would increase the number of ocelots in the state. It would also assure that there's a distinct population that would survive even if something catastrophic happened to those existing populations. So enter the ocelot reintroduction study that Dr. Lopez spoke about. It's really a new effort to re-energize ocelot recovery efforts by focusing on reintroduction. And so in the beginning of 2021, the East Foundation, which is a private landowner and agricultural research organization in South Texas that's involved in ocelot research and conservation, it brought together wildlife experts from a variety of partner organizations to investigate the feasibility of doing an ocelot reintroduction in Texas and also to develop some plans for doing so. And so the partner organizations, they include universities across Texas and the country. There's wildlife and zoological conservation organizations. There's also the Texas Parks and Wildlife Department and the Fish and Wildlife Service. And while we're looking at the names of all the partner organizations right here, I just wanted to say thank you to all the wildlife experts and organizations for being part of this study, for working on ocelot recovery, working on the objectives I'm going to talk about today, and being willing to work with me as well. So thank you all. So the partner organizations came up with 4 objectives as part of this ocelot reintroduction study. The first, and a team was identified to work on each objective. So a geospatial team looked at identifying a reintroduction site. A modeling team was going to do just that, model ocelot populations at the site. A captive propagation team was put together to look into breeding a source stock of ocelots, preparing them for life in the wild, and then actually reintroducing them to the landscape. And then finally, a policy team was going to integrate all of the information from these teams into one policy proposal for ocelot reintroduction. And my role in the last 2 years has really been to serve as a coordinator of these different teams. I've worked with them to help them meet their objectives. I've tried to coordinate communication between the different teams and with a project leadership team that's made some key decisions along the way. And so with that, I am going to turn to our first objective that I worked on with the geospatial team, which was to identify a reintroduction site in Texas. And the International Union for Conservation of Nature has a couple recommendations for how to go about choosing a reintroduction site. It needs to be large enough to support a population and not just a few individuals. It's got to have appropriate ecology for the species to make its living there, reduced human or natural threats to the species, and then because it's a human world we live in, it's got to occur in a favorable socio-political environment, that reintroduction. And we think that socio-political considerations might be especially important in a state like Texas, where the majority of lands are private working lands. In fact, where over 97% of land is privately owned in Texas. So any wildlife conservation project invariably is going to have to occur in and around private lands with the support of private landowners. So the study area for looking for an ocelot reintroduction site was about the southern third of Texas, including historic habitat and where the existing populations are found. And the first step in finding a site was going to look at ecology at really a landscape or a macro scale for ocelots. And ocelots are dietary generalists. They'll eat a wide variety of small and medium-sized animals. So it wasn't prey that was looked at for ecology, but rather landscape cover type. And previous research by Lombardi and others at Caesar Clayburgh had investigated suitable landscape cover for ocelots in the existing populations in Texas. And Lombardi et al. Found the appropriate structure of communities of woody landscape cover for ocelots. They found that large patches of woody cover occurring in low densities are highly suitable for ocelots, and they mapped that highly suitable landscape in the dark green there over about the lower 18 or 19 counties of Texas. So this map of appropriate landscape cover was applied to the entire study area here. And you can see that there's a lot of woody cover in the southern part of Texas. The next step here after the landscape scale cover had been looked at was to look at possible threats to a reintroduced ocelot population. So first with threats, establishing an ocelot population that will not be impacted by coastal storms or hurricanes is one of the goals here. So to be conservative, any areas that could be inundated with a foot of water during a Category 5 hurricane were removed from analysis. So you see the coastal areas go away there. Additionally, roadways can directly impact ocelots or their habitat. So any area within 1 kilometer of a high-speed roadway was eliminated. And then finally, urban development could destroy habitat. So any area predicted to be developed by 2050 was removed. So you see the urban sprawl around San Antonio and the Rio Grande Valley go away there. Even removing these threats and then after delineating all the remaining suitable landscape cover into patches, there's a lot of remaining patches. And there needed to be a way to identify really what the best possible patches might be for ocelot reintroduction. So a ranking process was used here, and this was actually the first part where some socio-political considerations were brought in. So it's really assumed that most of this area is going to be occurring on private lands, and a couple factors in the arrangement of private properties were going to matter. First was going to be the fragmentation of land ownership. So how many different landowners are there in any given patch of woody cover? It was really assumed that having more landowners would mean more people to get the support of for the project, more to coordinate with, to do the reintroduction, and maybe more people to say, no, don't do this reintroduction, in my area. So from a logistics perspective, fragmentation of ownership was not helpful for reintroduction. It was also thought that there need to be some large parcels, some large ownerships for this ocelot reintroduction. The program's going to take some on-the-ground infrastructure and activities, and ideally some ocelots could establish on one property where all that infrastructure is. So it's believed that there need to be a large ownership parcel above 25,000 acres, which is about 100 kilometers square in any ocelot reintroduction site. So these two factors were brought into a ranking process that used overall 5 metrics. First, fragmentation, the size of the area divided by how many landowners there were. Next, how much area fell in really large parcels above 25,000 acres. What was the size of the very largest parcel in that patch? How far is that from a high traffic roadway? And then overall, what's the size of that patch of suitable landscape cover? So each distinct patch of green received a normalized score on each of those factors, and then an average score, and patches were ranked by the average scores. And through this ranking process, it really fell out that there was 5 highest ranking patches for ocelot reintroduction. There's 2 towards the north that are opposite a roadway, 2 central ones also opposite a road, and then 1 towards the south. And these occur obviously in a wide geographic range. Those northern ones are more in ash juniper types of communities in the Edwards Plateau and Canyonlands. And then the central and southern ones do fall in Texas Tamaulipas and thorn scrub. So all of this has been done at a landscape scale to find 5 patches that look most suitable for ocelot reintroduction, but it was all at a macro scale. So there was also some interest in looking at ecology for ocelots, looking at vegetation structure at a finer scale within those patches of woody cover. And there's 2 metrics that were of interest for vegetation structure within patches. Those included canopy height, so really thinking about, is it tree cover or more low shrub woody cover? And then also, what's the density of the vegetation at a 0.5 meter to meter height where ocelots are really experiencing the world? So these vegetation structure metrics were remotely sensed where existing ocelot populations are known to occur. And then any areas that fell within 2 standard deviations of the mean for both canopy height and vegetation density were classified as suitable fine scale cover for ocelot. And suitable, looking here, the suitable fine scale ocelot cover has been overlaid in the dark green on suitable landscape cover in the light green. And you can see here that there's a lot of fine scale cover for ocelots in these patches, and it's pretty overlapping with the landscape cover. We're talking about hundreds of square kilometers of suitable ecology for ocelots. And given the size of these patches, there was also some interest in looking at how many ocelots these areas could potentially support. Previous research done on the existing ocelot populations by Lombardi and others found that there are 17 or 18 ocelots per 100 square kilometers. So just applying that density estimate to these patches, we can see that they could support a lot of ocelots. The smallest one, the southern patch, predicted to support maybe 63 ocelots, and then that very northern one, 255. And these are rough estimates because they were captured where the existing ocelot populations are and applied to a distinct area. But I think it really gives you a sense of just how large these areas are and how many ocelots they might support. So all of these areas look like suitable candidates for doing an ocelot reintroduction. They're big, they have appropriate ecology, they've got logistically feasible land ownership patterns. But the reality is that these sites all occur almost exclusively on private lands. So the ability to actually implement an ocelot reintroduction is going to come down to the socio-political side and the landowners. And when partners thought about the socio-political situations around these patches, it was really determined that the southern patch was going to be the best place for an initial ocelot reintroduction, even though it's a smaller patch. And there's a variety of reasons for this, but really chief among them was that 30% of the cover for ocelots in this patch occurs in just one single property, and that property is owned by project partner, the East Foundation, which is, a project proponent that's going to be committed and supportive of doing the on-the-ground conservation activities, as well as working with the neighboring landowners to get their support and approval for this project as well. So I think that in no way should the selection of this site, invalidate the future utility of those other areas for ocelot reintroduction, but really based on the known favorable social situation at this patch, this is the best site for an initial reintroduction of ocelots in Texas. And so in the project, after that site was identified, it was then time for me to work with the modeling team on doing some population modeling of ocelot reintroduction at that site. And the modeling effort was going to build a population viability analysis model of ocelot reintroduction into this site, with the goal really of comparing some different possible release strategies to help with initial planning for what this program is going to look like. So the model is like this. There's a reintroduction area that has 0 ocelots in it, but some ocelots are going to be added here. There's going to be the potential to add ocelots in a 0 year. We have the founders, and then for up to 15 subsequent years and some supplement releases where ocelots are added in later years. And I'll note that it's assumed that all of the reintroduced ocelots are going to be sourced from a captive breeding program. There's been interest in the past in getting ocelots from wild populations in Mexico and translocating them to Texas, but this hasn't been achieved yet. And it's really assumed that a captive breeding program that propagates ocelots and prepares them for the wild is going to be needed to supply the source stock, if you will, for reintroduction. And because that captive breeding program is going to be new, and it's not going to be providing a prolific number of ocelots, it's going to be a limited number available for release in any year. So given that, we wanted to test if it's feasible to build a population from some small numbers and then explore some different possible release strategies. So in comparing release strategies, first there's interest in looking in the number of founders in that 0 year. Is it better to have more individuals release that first year, say 6, or lower, say 3? Next, is it necessary to do supplement releases in later years? And if it is, should those subsequent releases go on for 5, 10, or 15 years? Do they need to go on an annual interval every year? And then is it better to have more released in each supplement release, say 4, compared to a lower number of 2? So if we look at this table of all of our possible release strategies, there's basically 10 supplement strategies and then 2 year 0 strategies. So for a total of 20 strategies that we wanted to test here for releases. And so how the model would work is that all 20 of these strategies would be tested for the reintroduction. And then when ocelots are released, we assume that 67% of them, about 2/3 would survive, and then the other third would die in that first year after release. And if there happened to be a severe drought that year, there'd be a 16% chance of that every year based on the climate. They would have a little bit higher mortality. But of the ocelots that survive at the reintroduction area, they're going to be able to establish a population. And based on the size of that area, it's assumed that the area has a capacity of up to 63 ocelots. So the population could grow towards that capacity. And it would go through all of the ocelot's normal demographics and life history. So that would include some of the resident ocelots are going to die more often in drought. They're going to reproduce a little bit less often in drought, and then young ones are going to disperse out of that population. So all this life history was modeled, and the parameters on ocelot life history were captured from the existing ocelot populations in Texas in some previous research that found the mortality of ocelots at different age and sex classes, how much they reproduce, how those severe droughts impact survival and reproduction, and then how much they disperse. So in this model, all 20 of those release strategies would be fed in different iterations, as well as all the life history information to model. And ocelot reintroduction was modeled out to 30 years, and for each strategy it was tested in 500 iterations. So for each strategy, the result was a mean population abundance after 30 years, as well as an extinction risk. So really what's the probability that that population is going to be extinct under this strategy after 30 years? So to look into the results here, the first thing to ask was, does that initial release in year 0 matter? We're looking here at the 10 different release strategies for their population abundance after 30 years. initial releases in black versus gray for the smaller initial release. You can see here for any strategy, a higher initial release of 6 versus 3 animals leads to higher population abundance. So I think unsurprising that releasing more animals is better for the population. But interestingly, even after 30 years, the number released in that first year still might matter for having a higher population abundance. The next question was, are supplement releases of ocelots necessary? And we're going to look here at the extinction risk for these different strategies after 30 years. And if you look at the no supplement strategy, it's got an extinction risk of over 90%. So that shows you that if just a few ocelots are released in that 0 year, there's a very low chance that that population is going to be viable after 30 years. There needs to be some supplement releases to have a lower extinction risk. And so what are the best looking supplement release strategies? If we look here, our 10 and 15 year high supplement strategies, those are ones where 4 ocelots are added every year to the site for 10 or 15 years. Those have much more acceptable results, right? Extinction risks of less than 10%. So a much better chance that those strategies could create a population that's going to survive out 30 plus years. And when we compare some of these backload and front load strategies, those are still for 15 years, but they're either not annual every year or they don't release for every year. And those a little bit less committed strategies have higher extinction risks, over 20%. So they might be, less successful strategies. And then of course, when we're looking at the best strategy in terms of population abundance, unsurprisingly, it's those 10 to 15 years of adding 4 ocelots every year. It's projected that that could result in some populations above 30, maybe even up to 40 animals at this reintroduction site. And when you recall the size of the known ocelot populations in Texas, these release strategies could produce pretty comparably sized populations. So really pointing that this reintroduction effort is going to be worthwhile, right? The other thing to think about here is that all of these projections are assuming that 1/3 of the ocelots are going to die in that first year after they are released. And there was some interest in looking at what might happen with the population if that first year mortality risk was varied a little bit. So in a sensitivity analysis here, the mortality rate was varied by 50% higher mortality. So that would be 50% die, and then 50% lower mortality where 16.5% of them die after release. And looking at a little table of the results here, you've got your population abundance and then the extinction risk in parentheses. And you see that even if they die 50% more than was originally assumed, that extinction rate stays really low at just 4%. The population abundance isn't going to be high, but the population has a good chance of still being there. And if it can go the other way and they die 50% less than was assumed, that extinction rate stays really low and the population abundance could be even higher than projected. So projected by these models. So really the takeaway on that is just how important it is to look into different management strategies that can be used to reduce the mortality of ocelots after release. That could be things like supplement water sources to help them survive in droughts. That could be really improving in the captive breeding program, their training against predators or learning how to hunt to be sure they survive as best as possible and the population does well. Thinking about recommendations numbers-wise for what this strategy needs to look like, we saw that larger initial releases matter. Doing 6 is better than 3, right? And that still matters for 30 years. Additionally, the partners, I think, need to be aware that it's going to take a long period of supplement releases to build this viable population. Just adding ocelots in that 0 year is not going to create a population that lasts. There needs to be 10 to 15 years of supplement releases consistently if possible. And so it's important to secure access to a sustained stock of ocelots, 40 or 60 plus ocelots over this period, and really assure, sustained resources to be able to continue doing this on the ground conservation work for 10 to 15 years. One more thing I want to point out here is that a lot of wildlife reintroductions actually fail to monitor their animals after they're released. So it's important to use methods like collars, like cameras, to actually measure how much they are surviving, evaluate the outcome of the project, as well as capturing actual ocelot life history information at this reintroduction site. How much they survive, reproduce, how they use the habitat and disperse, so that all of this life history information can be put into the model rather than relying on life history from the existing populations. And as this model gets new data into it, it can be revised and you can continue to test ocelot reintroduction strategies in sort of an adaptive management framework. Or possibly it's seen that, more ocelots need to be released over a longer period than was initially thought, or maybe something shorter. So I just emphasize that this was an initial look at what reintroduction planning needs to think about for doing this program, but I think it's just the first of many ocelot reintroduction modeling efforts. So with that, that's actually going to wrap up the science portion of my presentation. From here, I'm going to turn over to thinking about policy for ocelot reintroduction and other endangered species conservation on private lands. It's a really excellent year to be talking about endangered species because this is the 50th birthday of the Endangered Species Act this year. And folks, when they're thinking about how the Endangered Species Act has performed in its first 50 years, some folks are going to talk about 3%. And that's the number of species that have actually been recovered and delisted from the endangered species list in 50 years. Only 3% of listed species are recovered. So of course, in the next 50 years, there's a lot of interest in improving those recovery rates. And one area to do that is on private lands. So I gotta fly. The Endangered Species Act, sometimes rather than incentivizing recovery on private lands, can actually disincentivize recovery. That's because the Endangered Species Act prohibits the take of endangered wildlife, and the definition of take includes harm to species through modification of their habitat that could ultimately lead in injury or death of the species. So this kind of incidental take of species through modification of their habitat during land use is prohibited without a permit, right? And for a private landowner, regulation on incidental take of species through land uses could sound a lot like restrictions on private land uses. And so landowners who are concerned about being regulated due to endangered species are kind of incentivized to either withhold information about endangered species being on their property, so the government has no information to regulate them. We see that as a problem with our ocelot populations on private lands in Texas in some places. And then some landowners might be incentivized to just try to keep endangered species off their properties at all. That's historically been a problem. We learned with the red-cockaded woodpecker in the Southeast. So there's been a lot of efforts in the last decades to give landowners assurances that they won't be regulated on incidental take and their land uses if they can do some positive things for species conservation. And these sorts of regulatory assurances about land use are talked about a lot for conservation on private lands. But this case study of the ocelot reintroduction really allowed for looking into other things that matter for private land conservation. And recall in this case study that this whole effort has really been championed by a private landowner, the East Foundation, that isn't trying to hide information about endangered species or keep them away, but actually add endangered species to their property, right? And this landowner is supportive of doing the on-the-ground conservation, bringing together the partners, getting the permits, working with the neighbors as well. And so I worked with the policy team to develop a policy proposal to do ocelot reintroduction on East Foundation and other private lands. And of course, the East Foundation was still interested in some regulatory assurances to protect land uses on their lands and those of their neighbors. And it was really determined that there was going to be two policy mechanisms for possibly doing an ocelot reintroduction on private lands while protecting the landowners. So one option was a 10J rule under the Endangered Species Act, A 10J rule, if it's approved following public comment and federal review, it allows the Fish and Wildlife Service to reintroduce a population of an endangered species to some area without all the usual prohibitions on take. So it can be written that, say, some level of incidental take of that reintroduced species can be allowed. And then private landowners know that even when an endangered species comes to their area, their land uses will not be restricted. Another option for doing ocelot reintroduction on private lands was going to be a little different, the safe harbor agreement between a private landowner or landowners and the Fish and Wildlife Service. And in a safe harbor, a private landowner agrees to do some positive thing for species conservation, such as a reintroduction. And then in exchange, the Fish and Wildlife Service assures the landowner that they won't be subject to additional required conservation activities, and they can be allowed some incidental take of the species that occurs due to land use, so long as that isn't going to outweigh the overall benefit of the conservation work. And so working with the policy team and the East Foundation, it was really determined that a safe harbor agreement was going to be the best policy mechanism for doing an ocelot reintroduction. And in the process of choosing the safe harbor agreement and then subsequently working to develop the proposal for a safe harbor, there's been a couple findings about private lands conservation that I want to share. So first and foremost, the design of a private land conservation program matters. If you think about landowners, they might go back right to black and white days. They've been on their lands for generations. They have expertise, and they're probably pretty familiar with the notion that circumstances change, and it's important to be flexible and adaptable with land management. When you're thinking about ocelot reintroduction, it's the first time that it's ever going to be implemented in Texas. So invariably, things are going to be learned once the program's implemented, and the management is going to have to adapt with that new information. So whereas the 10J rule that I mentioned has to go through a federal rulemaking process every time it needs to be revised, the safe harbor agreement really belongs to the landowner, and it's more straightforward to revise. So it's really believed to be a better fit for the initial ocelot reintroduction because it's well suited for adaptive management. The other nice thing about the safe harbor is that it's not permanent. It's flexible in that the landowner and the Fish and Wildlife Service determine the length of the agreement. And then if the landowner ever has, a personal situation come up where they can't do the conservation work anymore, they can always end the agreement early. Another important thing that happened while developing the safe harbor agreement really showed the importance of previous experience in private lands conservation programs. So the East Foundation actually shared that it had already been part of a safe harbor agreement for wildlife reintroductions, an agreement administered by the Peregrine Fund to reintroduce northern Aplomado falcons. And the East Foundation reported that it had a positive experience participating in a safe harbor before. It felt comfortable participating in a safe harbor again, and that it really was going to have the ability to demystify this process to other landowners, sell it to them, and get them to join in on a safe harbor as well. So I think this really highlights just how a landowner who has done some private land conservation before might be really primed to participate in a similar program again, and they can be engaged as a champion of that program to get other landowners to do it as well. And then finally, when we're talking about private lands conservation, I think it's important to point out that the East Foundation isn't going to do this ocelot reintroduction because they're being promised, some payout from doing it or some incentive. Really, they're doing it because they have a mission to promote land stewardship. And I think landowners all over the United States have this ethic that they need to be good stewards of their lands and the species present there. And I think that the land stewardship ethic can really be capitalized on for getting landowners to sign up for these endangered species conservation programs. And it might be especially easy to do this when we're talking about charismatic species for the ocelot that people already have, heard about and have some interest in. So these types of species might be really good for getting people to engage in a private land conservation program at first, that maybe they'll do subsequent programs too. So all of this information has been important for developing the safe harbor agreement for ocelot reintroduction. I think it really can be applied a lot wider than Texas. There's a lot of private lands across the United States, and some of these considerations can be really important for getting private landowners to work on species recovery in the next 50 years of the ESA. So let me review what I've talked about here today. I told you how the geospatial team identified that southern patch partially owned by the East Foundation as the best initial ocelot reintroduction site. It's believed that up to 63 ocelots could be supported in that area, and the population modeling team found that it's going to take 10 to 15 years of efforts to build up a population that's going to be viable there. I didn't really get to talk about it today, but please know that the captive propagation team, as we speak, really is working on plans to breed ocelots, to prepare them for life in the wild, and then actually reintroduce them to the landscape and monitor them. And then I told you that the policy team chose a safe harbor agreement as the policy mechanism for doing ocelot reintroduction. And right now that team is finalizing really the proposed safe harbor agreement so that can be submitted for ocelot reintroduction. And meeting all of these objectives has really just created a path forward for doing an ocelot reintroduction on the ground and implementing all of this. And recall that reintroduction, it's going to increase the number of ocelots in Texas and in the United States. It's going to reclaim some of the historic ocelot habitat in Texas, and it's going to assure that there's ocelots in Texas and in the United States, even if those existing populations are lost. So I say I'm really inspired to think about the future of ocelot recovery here in Texas. I was inspired as well by the work of all the folks on these different sub-teams that I worked with today. I wanted to say thank you to the geospatial modeling and policy teams who worked on the objectives I talked about today. And thank you to all of those folks. Appreciate you. And wanted to acknowledge as well many folks part of the captive propagation team and leadership team on this ocelot reintroduction. We appreciate everybody's work there. Thank you as well to the department and to the university for the Avalis Johnson Fellowship that supported my ability to work here. And then thanks as well to the Ronald F. Labisky Graduate Fellowship and Wildlife Policy through the Wildlife Society, as well as the East Foundation for making it possible for me here. So thanks to everybody for joining here in the room and online as well. And I'm happy to talk about anybody's comments or questions. Thank you.
All right. Thank you, Lindsay. So we will alternate with questions. Those online, if you have a question, just raise your hand. And those in the room, just raise your hand as well. Let's start with Dr. Mohammed.
Lindsay, you thanked everyone, your committee members, us for attending and your teams, but you did not thank yourself. So it's good to thank you for excellent presentation. Really good talk. I enjoyed it. And I thank your committee members for designing for the really hard work and how you put this together. I have, two quick questions. What are some, so when you pick your sites for reintroduction, did you consider the natural enemies? What are some natural enemies for ocelots?
Yeah, good question. I think there's interest in bobcats and coyotes that exist in Texas. Mountain lions sometimes exist in Texas as well. And those could be potential predators of ocelots or competitors. But ocelots in the existing populations do share habitat with both bobcats and coyotes. So we know that they can coexist. And there's been some research from Caesar Kleberg that they can kind of split up their habitat use over space and over time. So it really wasn't thought that the presence of bobcats or coyotes would negatively impact the presence of ocelots. And I think that the exact interactions and how those other species might impact ocelots isn't quite known. And there's not known densities of bobcats and coyotes across South Texas there. But yeah, that's definitely something to look into with the management.
The other point I wanted to make, so you use the term reintroduction, so which is different from introductions. Reintroduction means the animal was there before. So for all the sites you said you guys pegged, did you look at why the population disappeared from this specific site, from those specific sites before we reintroduce them to make sure that the animals have a chance to survive and repopulate?
Yeah, that's a great point. And the site that was selected, there's no on the paper records of ocelots being present on that property. I think it was, assumed that because ocelots existed in southern Texas and there's records of them along the border, along some different rivers and in the hill country, it was kind of assumed that they were populating areas in between. But as far as having the actual records of where they were and what caused them exactly to be lost there, if it was mostly the overexploitation versus the habitat loss, that information wasn't in there. But yeah, I think there was some interest in looking at, should it be called reintroduction or introduction? It wasn't known if they were precisely there before, but we stuck with reintroduction, assuming that ocelots had probably occupied a lot of the southern Texas historically.
Thank you.
Thank you. Appreciate
I'm
it.
gonna go online, Bill. Any questions online? Go ahead, San Antonio.
Peace Foundation.
Hey, Lindsay. First off, congratulations. That was a challenging project. You had, it's one of those projects that is challenging at the front end, and then you have definitely come up with some stuff that's going to help us move forward. So as you're looking at the future prospects for recovery, I know you've met the challenges that we've addressed so far in a pretty methodical way. If you were to, and we're going to keep you around, so you're going to have to face the future challenges that are coming. So if you were to project out 2 to 3 years from now and predict what our challenges are going to be at that point, what would they be?
Thank you, Neil. Great question, thinking about the future. I'll point, I think, to two things here. I think one is that the hope is that this ocelot reintroduction maybe could be just the first, and that some of those additional sites could be used in the future as well for establishing more ocelot populations and reclaiming more habitat. I think, Neil, that a challenge there is going to be in working with the private landowners and securing their approval and support for reintroductions in other areas. And I think ocelot recovery has been challenged a lot by coordination with private landowners in the past historically. So continuing that private landowner outreach is going to be important. And I think that the East Foundation as a private landowner itself can continue to be a champion for ocelot recovery and conservation on private lands that can hopefully get more folks on board. And then just the challenge, on existing populations. I didn't talk even about conservation for them, but there's continued work to do for the existing populations. I mentioned that they're distinct and isolated right now. Finding a way to connect those populations through translocations or through habitat connectivity is important, and doing other things to keep growing the size of those existing populations in addition to reintroduced ones. So thank you, Neil and East Foundation folks. Appreciate you.
Thanks. Great work, Lindsay.
Thank you. Appreciate it.
I have a question here in the room from Dr. Fox.
Yeah, Lindsay, great presentation. Thank you very much. I know you didn't go much into the captive propagation team, but just in general, how long does it take to train up a ocelot? And that number that you put up there, was it 46 to 66? Is that yearly population need?
Yeah.
Or propagation need yearly?
Mm-hmm. Okay. Yeah. Thank you for clarifying that. So the 10 and 15-year high supplement strategies were the best ones. And so those ones require 46 to 66 over 10 to 15 years.
Over 10 to 15.
Yeah, exactly. So it's assumed that in those strategies, there would be, say, 6 ocelots in the 0 year and then 4 in each subsequent year. So that's going to be over time. I think if there was 46 to release at once, that would be awesome.
Yeah, I was just wondering, do you have to have 46 to 66 every year?
Yep.
To get a population?
Right, 4 per year. And just to give folks, I guess, a sense of what the captive breeding looks like, it's thought that based on some examples from other cat breeding and behavioral preparation and reintroduction programs, that the cat is, born with the mother, and then it lives in sort of a semi-wild but safe outdoor enclosure where it gets to learn how to explore around, use the environment, hunt, until it's around 1.5 years old. And that's when ocelots will normally separate from their mother. So around that age, the mom would be taken away. They would keep practicing their behavioral preparation for a bit. And then when they're between 1 year to 2 years old would be when they would be put out on the landscape. And I think the younger animals have a little bit more plasticity they see often in their behavior. So they might be better suited to release than an older animal that wants to go back home or something like that.
Thank you.
Yeah, thank you.
Thank you, Bill. Online, any questions online? Or in the room? Dr. Wardell has a question. Go ahead, Ty.
Great presentation.
Thank you.
You touched on it a little bit when you're talking about connectivity and isolated populations. When you're looking at spatial modeling, did you try to find areas that may be connected to populations currently in Texas and there just wasn't any?
Right. So I think a couple things. There was interest in having this population actually geographically distinct because we didn't want it to be impacted by the same potential catastrophic events that could impact the existing populations, such as the hurricanes or the disease outbreaks. And I think as well, because it's going to be coming from a captive breeding program and there's some genetic considerations in there, not having those populations naturally connected at first was of more interest, and having the ability to connect them through translocation. But the reintroduction site is going to be about 100 square kilometers away from the existing populations and on the opposite side of 2 north-south state highways. So there's not going to be natural connectivity there unless a lot of habitat can be created in between and some road crossings. But yeah, really the goal here, I don't think, was to create something connected to the existing populations.
Great presentation. For the 6 or 3 individuals, were you aiming for a specific sex ratio, or is it all opportunistic on what the captive breeding program has?
Yeah, I think.
Repeat the question.
Yeah, I was gonna say, Connor's asking about if the sex ratios of the released animals was looked at, or if it's just gonna be opportunistic which animals are released in any year. And that brings up a good point that no matter what we model, the number available for release is gonna depend on the success of breeding and the success of the behavioral preparation. So that's gonna vary each year. But with that, it was assumed that it's better to have more, a little bit skewed towards more females than males. So in that initial one of testing 6, it was 4 females and 2 males. And that's because of the ocelot's ecology, there can be a couple females on one male's territory. So skewing a little bit towards more females was assumed there. But I think you're right, the number available for each year is gonna matter. Question?
Dr. Tuis online had a question.
Hi, Lindsay. Excellent presentation. Good job.
Thank you, Dr. Tuis. Appreciate it.
Very good. I was just wondering, you mentioned that, and we've seen how ocelots coexist with coyote populations and bobcat populations, and they've done it through time. We see that consistently of existing wild ocelots. One thing that'd be curious that you'll find out early on in the releases is what will naive captive cats do the first couple of nights they meet a bobcat or coyote. And that, I think, will be, it may well be different. It may be quite different. And so it'd be a really kind of something to watch out for. And it may require some adjustments at that time. Just a thought.
Thank you, Dr. Tuis. For those who don't know Dr. Tuis, he's the lead of the feline research group at Caesar Clayburgh. And I think just to jump off his comment, there's going to have to be adaptive management with this. And if he's saying, the fate of every ocelot released is going to be known. And if there's some problems with bobcats and coyotes, that could be an area for adaptive management. And of course, in the captive breeding, facility as well, some training for predator avoidance maybe could go on as well. They've done that for other species. Thank you, Dr. Tuis.
Got a question. Can I jump in?
Yes, please.
And it kind of to follow up on the ratio of males to females that are released. And I think I know the answer, but will you be releasing pregnant females?
Right. Good question from Tyler on which animals to release. So there's been some research on reintroduction of Canada lynx that showed that releasing the pregnant females or the ones with young is very stressful for them, and those individuals don't survive as well because they've got so many more requirements that they have to be meeting. So any animal, you know, with a pregnant or lactating reproductive status, going through any type of injury, illness, or concern would not be a good candidate for release because there'd be concerns about their ability to survive. And then the individuals to be released are assumed to be in the 1 to 2 year age range, because that's when they naturally want to separate from the mother and go establish their own home range. So a pregnant ocelot would probably be at least 3 years old, I think, or older. So no release of pregnant females planned at this time, but I suppose there's always adaptive management, you know, if things need to change.
Thank you.
Yeah.
I've got some hands online. I can't see who has a question. If you have a question online, just unmute yourself and ask a question, please.
Grant, are you there?
Yeah, I am. Thanks, Lindsay. Awesome presentation. Really enjoyed it and very informative. My question is, you know, this project has garnered a lot of interest from the conservation community watching it, you know, from all different levels, be it state and federal and private. And I guess, you know, what's crossing my desk is, you know, interest in saying, hey, you know, can we do something similar with Atwater prairie chicken, or something more at Atwater prairie chicken, or do something more at black-footed ferrets? And I guess there's two ways to ask this question, but the way I think I'm going to ask it is, looking back, now that you're an expert on this and you've been working on this, you know, very focused for a number of years, what advice would you give to yourself starting out, or what advice would you give to the agencies that are embarking on such an effort to say, hey, you know, pay more attention to this or pay less attention to that, but what kind of lessons learned, if you have them in your head, that you could kind of put forward and say, if you were to do this again, what would you do differently, or how would you approach things, or what would you pay more attention to?
Thank you, Grant. Appreciate that. I think some of the most important things from this project that maybe could be applied elsewhere, first and foremost, would be the partnership. This is such a unique effort, I think, in having all the different partners and really having the private landowner kind of be a lead on things and have that private landowner perspective. And so I think, you know, doing this type of collaborative conservation that we've been doing in this project could be really useful for other projects, and letting the agencies be a partner, but letting private landowners find some conservation organizations to join in as well, like we've done. The other thing I think that's been great for ocelots is that there's a lot of existing research on those existing populations in Texas through the Caesar Kleberg and the East Foundation. So having all that research ready to go was really helpful for the site assessment and for the population modeling. I would say with that, Grant, we've definitely struggled with some, you know, maybe uncertainties on things. You know, not exactly sure what the ocelot carrying capacity is going to be at the reintroduction sites, or how landowners might be. So I think some advice is, you know, having a plan for how to address uncertainty and how to work with the project leadership like we did to know when it's important to make decisions, and how we can, you know, deal with uncertainty and limited data could be important. But I think, Grant, this could be hopefully a model for other recovery efforts, like you said there, and hopefully we've done a good job on documenting the process.
Yeah,
Sorry, Grant.
no, all done. Thank you.
All right.
Thanks, Grant.
Mike Brennan.
Thanks, Roel. Lindsay, great presentation. To build on your last point, what was communication with neighboring landowners is pretty key to enlisting support or even tolerance. Could you discuss how communication strategy was considered in the project?
Yes, thank you, Mike. I guess I didn't talk about this, but one important thing at the beginning of this project was just to establish for public communications what this project was, what the process was going to be like, and also what it wasn't. So when the project was getting going, we started a public website called recovertexasocelots.org. And that just explained that it was going to be a collaborative process to look into reintroduction. But an ocelot reintroduction wasn't going to occur anywhere without the landowners being on board. And always this project has been centered in a goal of promoting ocelot recovery and also something that's going to work for landowners. And so when it came to do the sort of socio-political check, let's say on some of those top 5 potential reintroduction sites, there actually wasn't outreach to all the different landowners because there was some concern about putting out information about the project before things had gone along, potentially talking to people that then their property wasn't going to be chosen. So the way that landowners were kind of considered was more by working with some locally relevant partners, such as the private lands biologists, the Texas Parks, Caesar Clayburgh, and the East Foundation that already had a sense of what these landowners might feel about doing an endangered species recovery program. So of course we had the benefit of the East Foundation already knowing its neighboring landowners, and then Caesar Clayburgh had done research on other private lands and seeing which landowners were likely willing to be engaged with this, and which landowners are interested in endangered species research or conservation on their properties. And then I'll just say that as the safe harbor agreement proposal goes in, and if that can be accepted, there's going to be a lot of work to do some landowner outreach to get folks to sign up to be part of that safe harbor and to join the East Foundation to really support this ocelot conservation work. Thank you, Mike.
Thank you, Lindsay.
Appreciate it.
All right, any other questions in the room or online?
I got a question about genetic diversity. I guess that's the genetic diversity in the captive breeding and reintroduction has been of interest a lot. And I'll just say that there's kind of 2 goals for the genetics of a reintroduced population. The first is that it needs to incorporate some local or ecologically similar genetics so that the species can be adapted to the environment. And then also it's really important to have the highest levels of genetic diversity possible so that the species can have the population can have adaptive capacity to change in the future. And especially when you're considering a small reintroduced population, trying to have a lot of genetic diversity is important for avoiding inbreeding, depression, or some other issues. So that could be a challenge for sure.
All right, anything else? If not, we'll thank the folks online and in the room. We'll take a 5-minute break.